I mentioned this before, but I gotta say it again. If you're using C++ on Windows, then this is a makefile. I opened the makefile file. Has no extension. There's this line right here that says C flags equals dash wall dash where dash wishadow dash pedantic. If you use Windows, please edit this file and delete that stuff. Here's why. It would be very difficult for you to code in such a way that you don't trigger one of those warnings. And when you submit to my server, it tries to build on Linux, and those flag everything possibly wrong with your code. If you remove that, then my auto greeter will just work a lot better. And if there's other porting issues, if you get the file name and the backslash thing right, and you remove those, at least every submission so far has just worked. Those are the only issues I've encountered. So I think if you do that, then that'll greatly reduce the amount of effort on me for grading your stuff, because it'll all just work on my computer. And plus, it'll help you learn to write cross-platform code, which is a good thing for computer scientists to know, and so forth. So if you use Windows and you're on C++, please delete that stuff I've highlighted from the makefile. Okay. Sorry for burdening you with platform issues. That's not what this class is about, but it has to be done. Okay. Let's see. Oh, that's my list of stuff to talk about. Did that one? Okay. Pet peeve. When reading your code. This just really drives me nuts. Never do it. For int I equals 0, I is less than something. M dot rows, I plus plus. Let's pretend I'm doing Java now. Rand equals new random. Rand dot next int. And I equals. What is wrong with this code? Okay, you think you are generating a random number. In fact, this is not generating a random number. This is generating a new random number generator, right? And if you're generating a random number generator every time you need a random number, are you getting a random number? The answer is kind of maybe, but no. Here's why. Because random number generators don't really generate random numbers. They really should be called pseudo-random number generators, because what they generate is a big sequence of numbers that are chaotic, and for all intents and purposes, it's effectively random. So it's only effectively random if you keep using the next number in the sequence. If you generate a new random number generator, then you're always starting over at the beginning of the sequence, which means you're always getting the same number again, which means you're not getting random numbers at all. You're getting the same dumb number, which just happens to be random, which isn't random. Okay, we have to look up the XKCD one. XKCD random number. This is the XKCD random number generator. It returns 4. This is basically what you're doing when you generate a new random number generator every time you need a random number. Because it's always going to return the same number. Now, here's what makes that even worse. The Java random number generator, by default, doesn't require a seed. And when you do not provide a seed, what it actually does is it uses for the seed the number of seconds since January 1st, 1970. That's called the Unix epoch, something like that, multiplied by the process ID, or something like that. And they might throw in some millisecond precision things. What that does is it makes it so that every time you make a random number generator, you get a different sequence of random numbers. Now, if you're inside of a loop and your computer is fast, every time you generate a new random number generator, it will presumably the number of seconds since 1970 will not have yet changed, and the process ID will not have changed, and so you'll keep generating the same random number sequence. But if you run the program a second time, and it's more than 1 second later, you'll find that in fact you do have a totally different random sequence, which makes you think that this code is working. And so it's very deceitful, and people, not deceitful, it's confusing. People that do this think it works, and it doesn't. So I don't know how to say it other than this. Never generate more than one random number generator in any program ever, please. If you just do that, now I feel better about this code. I'm not angry anymore. Everything is good. Because you're not generating a new number generator to get each new number. Okay? I didn't take off any points for that. I'm just telling you it's one of my peeves, and I haven't even mentioned it before, so if you did it, don't feel bad. Just never do it again. Another thing, when I use a random number generator, I always seed it. Do you know what a seed is? It's the number you provide to the random number generator that tells it precisely which sequence you want to use. So does this make the numbers any less random? Well, it makes them totally predictable, but they're just as chaotic as they were before. Meaning the sequence is going to be, as far as your program is concerned, totally random. But every single time I run the program, it's going to behave exactly the same way. Why is that a good thing? Yeah, imagine you have a bug somewhere in your code, and you find that the bug occurs the 7,321st iteration through a loop. And you go through all the pain to get to that point in your code, and you're debugging it, and it doesn't occur there the next time. Isn't that frustrating? If you seed your random number generators, then your code becomes entirely deterministic. Plus bonus, if it worked on your machine, it's going to work the first time I look at it, and it's going to show me the exact same thing you saw. And then you can even play seed games where if you get bad results with this, then you change the seed and run again until you get decent results, then you submit it, and then I see the same decent results, and we all think it works. That's not really great behavior, but better to know what's going on than to not know what's going on, right? At least you're doing it deliberately rather than non-deliberately. In my opinion, you should only ever make one random number generator in main and then pass it around and always use it thereafter, or make it global or static or something like that. Was there a question?
Yeah. I was looking through the random class implementation. It's like they keep a static counter pretty much. It's like a seed unifier. And then they use nanotime with that to try to keep it as unique with every instantiation of a random.
Interesting. I don't know how I feel about that. What that does is that effectively means that this is going to work, but that's actually bad because it's encouraging bad behavior.
Yeah.
So, So, changing the seed doesn't make it necessarily chaotic. It just means that you're starting in a different position of the big, large random sequence. So that's going to make it look really random, even though it's not going to have the properties of a random number generator, which should satisfy a bunch of pseudo-random properties. So Java apparently works really hard to make this work. I don't know why. Don't lean on it. How about that? Okay. And one more thing I need to go over is just, let's talk about how cross-validation worked. I know I went over this, but it caused enough issues. I'm betting a lot of you are vague on it, and I just didn't explain it super well. So I'm going to just explain it again. Pretend my data. Let's do 5-fold cross-validation. Okay. Originally, I had some data that looked like this. And I broke it up into 5 folds, like that. Okay? I draw 2 rectangles to indicate that I have both features and labels. What are features? These are the inputs to your model. Labels are the target outputs of your model. And we use features and labels to train a supervised learning model to learn some function, right? We're training a function approximator. Pretend I took this data and I broke it up into 5 folds. How do I do cross-validation? I'm going to systematically withhold one of these folds, consisting of both features and labels, at a time. I'll withhold this one, then I'll withhold this one, then I'll withhold this one, and so forth. Okay? Until every fold has had its opportunity to be withheld. And at each point, I'm going to test by trying to reproduce these labels. And if I successfully reproduce those labels, then I declare success and I say yay, right? Of course, I'll never perfectly reproduce them. So what I do is I measure how far off the predicted labels are from the actual labels, and I sum up what I call sum squared error. Sum squared error. And sum squared error is defined as the sum of the squared error, where error is target minus predicted. Okay? So if error is target minus predicted, that means, let's suppose this is the fold I was withholding at some point, and there happened to be a number 3 there, and I predicted a number 1. What's my error? 2, right? Okay, what's my squared error? So I could say error is equal to 2, squared error is equal to 4. What is the sum squared error? Well, it depends what we're summing over. The sum of the squared error over this fold is the sum of all the errors that occurred in that fold. And the sum of the squared error over the whole thing is the sum of the whole thing, right? Now, the thing I asked you to report in your assignment was something called root mean squared error. And what's root mean squared error? Well, it's the square root of mean squared error. And mean squared error is the average of the squared error. Are you confused? If you are, probably you didn't read the section on the book about root mean squared error, because I probably didn't cover it well enough. But let me just go over it really fast, and yeah, I know you've already coded it up, so most of you get it. But here's the deal. Root mean squared error is supposed to be a measure of how far your predictions deviate from expectations. Does that make sense? It's kind of the equivalent of standard deviation, except we're measuring it not as how far you are on average from the mean, it's how far your predictions are on average from their targets. So if you wanted root mean squared error, you need to compute the right mean squared error, right? Which is the average of how far you are from your targets. If you wanted to do that, what sum squared error should you compute? Is that question making sense? What I'm saying is, if you sum all the values from every single fold, you've got a total of, well, basically every pattern has had its turn one time to be predicted, right? After all of the folds of cross-validation. Therefore, if you sum them all up, and then you divide by, what should you divide by to get mean squared error? The total number of tests that you've done, right? The total number of patterns, which should be all of them because you've done all of them exactly one time. So if you sum over all of the folds and then divide by every pattern, you get mean squared error. And then if you take the square root of that, you get root mean squared error, and that's the number we were going for. Okay? Is it clear what root mean squared error is now that we've gone through that? Okay. Sorry I didn't clarify that more clearly before you had an assignment due on it. But then again, it's a graduate level class. You had a book. It had a chapter on this. I even gave you a pointer to it in the instructions. I think most of you figured it out.